Okay, so here we have one more example from this section, and we are going to use the linear approximation for the fourth root of x at x equals 2. And so we just need to find the equation of the tangent line. So we start off by taking the derivative. So I can rewrite this as x to the 1/4. So the derivative is going to be 1/4 x to the minus 3/4. And then if I want to rewrite this without the negative exponent, it would be 1/4, and that 3/4 will become a fourth root of x cubed, right? And so we want to evaluate this at 2. So I'm going to plug in 2 to my derivative, and I will get 2 cubed with the fourth root. And so just simplifying this a little bit, that's the fourth root of 8. 4 times the fourth root of 8 in the denominator. Okay, and so I'm going to leave it in that form. And then we just need to evaluate the function at 2 as well. And so that is just the fourth root of 2, right? So writing down our equation of our tangent line, we get, so our point is going to be 2 and the fourth root of 2. Great. So it will be this is our slope, so 1/4, fourth root of 8, times x minus the x part of this point is 2, and then we add the fourth root of 2. Okay. This is the equation of the tangent line. I wouldn't simplify it any more than this because we are just going to rewrite it as the linearization and then plug our points in. Okay, now in this question it asks you to use the linear approximation or the linearization to approximate the fourth root of 3 and the fourth root of 10. Now what we get when we plug in 3 is we get this piece doesn't change. We get 3 minus 2, so that's just going to simplify to 1, and then we get that. So I'll just rewrite this step. Okay, and then we will leave it in this form, and we'll come back and actually give the approximate value. But first, let's plug in 10 as well. In that case, we get 10 minus 2, which is 8, and then plus the fourth root of 2. So we get 8/4, fourth root of 8, plus fourth root of 2. So we can simplify this one a little bit more. That's 2 over the fourth root of 8 plus fourth root of 2. Okay, so if you take this this value and plug it into your calculator, it will give you 2.37884. Okay, so that is going to be our approximate value. Remember, this is approximately equal to the fourth root of 10. And then this is the linearization at 3 is approximately equal to the fourth root of 3. Okay, and then we'll do the same for the linearization of 3. So I will plug this in and get 1.3379. And in this problem, you're asked to compare these values that we get from the linearization to the values you get when you plug these into a calculator. And the reason I'm asking, so the reason why I wanted to do this example is because notice that 3 is close to 2. It's not that close to 2, but it's somewhat close to 2. And so it makes sense to use the linearization at 2 to approximate this value. but 10 is pretty far away from the point 2. And so if we actually, so I want to compare this to the fourth root of 3. If we actually plug this in, this is approximately 1.361. So you see that it's not too bad of an approximation. The first decimal point is the same. The second decimal point is not that far off. So it's a decent approximation. So we're comparing these two values. But if we plug fourth root of 10 into a calculator, this will give us approximately 1.7783. So see, there's a lot more error between these two values compared to the first one. So the fourth root of 3. And so this is an example of you taking a point that is too far away, and so the linear approximation is really not going to give you a good approximation of the value of the function, right? Okay, so that is all for this section, and then we will also talk about section 4.1.